Alright guys, you're gonna have to bear with the wind noise on this. It's been blowing like crazy here in Southern California for the last few days. But let me talk about the story behind modifying some existing titanium heat brakes to fit my Artillery 3D Sidewinder X2. So let's dig into it. Alright, so first of all, to the best of my knowledge, I have not been able to find a single piece titanium heat brake that fits an Artillery 3D Sidewinder X2. And if you have found one, please comment it down below, because I would be more than happy to share it around with people. But to the best of my knowledge, all the ones on the market have way too long of a throat here, being this part. And the issue with that is it causes the whole hot end assembly to sit lower than the activation point of the probe. Being the probe is fixed, nozzle comes down, head crashes, and if you're lucky, maybe the probe will trigger, but that's not the proper way to probe your bed. So what I ended up doing is I took these really nice titanium heat brakes that I've been using for years on my X1 that I get on Amazon, and I'll have a link to the original ones in the description. They're very nice, they're very well machined, they're not super cheap, but I have not had any problems running them, and I've heard horror stories of lower grade heat brakes. I've seen photos. Buy once, cry once, be done with it. I'm moving on. So what I ended up doing is I came along and actually shortened the height of it. Now obviously I can't go removing threads on the bottom, and I do not want to mess up the very nice sealing surface that the bottom of this heat brake has. So I just came along on the top with the 3/16 end mill and just carefully went around the part, taking off quite a small amount of material per pass. I just did it as an adaptive clearing path in Fusion 360, just going circularly around it. But the advantage of that is it kept the load on the cutter consistent, which is key, especially on my little machine here. This thing is not very rigid, this thing is not very powerful, but that low speed gave me the ability to come along and easily get the material cleared out. This is titanium, by the way. I flame tested the chip, so it's not something else claiming to be that. And just taking it at a low RPM, a decent feed rate, it worked great. I did use a little bit of this OD dark thread cutting oil. This stuff smells horrible if you get it hot, but oh dang, does it provide some really good lubrication. Just brushed a little bit on there, nothing went wrong. While I was at it, I also put some flats here on the sides. Now the advantage of this is twofold. One of them is when you're rough assembling the hot end, it gives you a nice area to gently grip with, say, a crescent wrench. And then you can just gently tighten up the hot end assembly, all as well. And then when you get it into the printer as well, you can actually clamp to a flat surface, so you're going to get a much more positive locking action without stripping your grub screws, versus just trying to grip to the smooth surface, which can be somewhat problematic. Now when it came to installing this in the printer, all I needed to do was cut a 25mm piece of PTFE to act as a guide tube, slide this in there. This does sit very close to the heatsink, so keep that in mind, and pretty much just double check that the printer was going to probe right. My one recommendation is make sure that you have your finger on the power switch, so just in case this is sitting down too low, say you didn't get the PTFE in there high enough, or you cut it a little bit too long, keep your finger on the power switch to kill it, just in case. You don't really want to crash your head and tweak things. I'm not so much worried about bending the little throat here. It's relatively durable. It's more to do with just bending up the frame assembly, and you don't want to crash things. So if you are interested in purchasing one of these, I will have a link to them down below, to my Etsy store where I have the modified ones for sale. Now, I'm going to be very upfront and honest, these are not cheap for me to purchase initially. They take a bit of time for me to machine them, and that's why I'm charging what I'm charging. And currently, I'm only going to be offering the amount that I have for sale just because I don't want to be sitting on a ton of stock and it turns out that, nobody's really interested in these. That being said, if there is enough demand, I might consider doing a pre-order run of them. And if you want to get in on that and you weren't able to get in on the initial run, please let me know and I will see if I get enough requests. I'll figure out a system and we'll go from there. Now, I am happy to report that I was able to get quite a few PLA prints done using this heat break without any issues, which is very nice. When I initially run an all metal hot end, I do like to run a little bit of oil through it. I'll just take a piece of paper towel, rub some 3-in-1 oil on the filament using that, and that helps to season the heat break. Works great. I know some people say it's not necessary. I've always done it. I've never had any problems doing it. Just clean your bed when you're done in case there is any residual oil. But overall, I gotta say, I'm super happy with this. Now this gives me the ability, should I so choose, to install either a higher temperature thermocouple and or flash my X2 to print at higher temperatures. So now I can safely run nylons all day and not worry about just totally destroying my PTFE and releasing some really noxious fumes in the process. Trust me, you do not want to breathe that stuff in. Alright, hope you guys enjoyed, and I will see you here next time on Make It with Calvin.